Hey class, Dr. Yeager here again, finishing up chapter 3 here. Last time we were talking about the atmosphere and atmospheric pressure. Let's talk about water, because as we get into talking about weather, water is going to be really, really important. Move myself there so you can see. Almost all air has water vapor in it. Other than in places that are really dry, like deserts. There's some water vapor in almost all the air. Of course, just like most of the atmosphere, we can't feel it, can't smell it, can't see it. It's an invisible gas, right? It's water in its gaseous form. But we can kind of feel it. I think most of us would know if you'd been inside all day and if I came in and I said, oh my gosh, it is muggy out there, you would know what I meant, right? When you can sort of feel the moisture in the air on your skin. That's what it means when the air has a lot of water vapor in it. We'll get to how we can calculate that, right? Most of us know that we would say, oh, the humidity is high, or the relative humidity is high. If you ever watch the weather person, they talk about, just like they talk about atmospheric pressure, they talk about relative humidity quite a bit too, and that really impacts the way it feels. So we'll get there. How does water get into the air in the first place? Well, liquid water becomes gaseous water or water vapor through a process called evaporation, right? When a liquid becomes a gas, that process is called evaporation. And we've all seen this before. If you've ever boiled a pot of water for, pasta, you put water in the pot and you turn on the heat, and at a certain temperature, the water begins to boil. And so, of course, that's 212 degrees Fahrenheit. When the water reaches that temperature, we can see the bubbling of the water, and what we're seeing there is water molecules converting into water vapor, and the gas coming from the water, right? That's the boiling part of the water. If we were to measure the water vapor in the dry air right above the pot, it would be greater than it was before the pot was boiling, right? So obviously high temperatures increase evaporation. You don't necessarily have to have, of course, 212 degrees to evaporate water. Obviously, because water evaporation happens all over the place, and it doesn't have to be 212 degrees. For example, on a warm day, if you dropped your water bottle on the sidewalk and there's a little puddle of water there, if you went inside and came back out half an hour later, there's a good chance that that water might be gone. Maybe all of it's gone, maybe less, maybe, some of it's gone, but certainly some of that water would have evaporated. What are the things that could make that water evaporate faster? If it's a windy day, right? If it's a windy day, as that moving air moves over the top of that little puddle of water, it's going to pull some of those water molecules away, and evaporation will take place. So that's how water vapor gets into the air. And the amount of find a place for me to put my head. The amount of water vapor that is in the air is what we call the humidity. And air obviously can only hold so much water, or so much water vapor. So when you hear the weather person talking about humidity, usually what you hear them talking about is what's called the relative humidity. And so relative humidity is referring to the amount of water vapor that's in the air as opposed to the total amount of water vapor that the air can hold. Okay. And so on a day where you walk in and you're like, oh my gosh, it's really muggy out there, the relative humidity on that day is possibly close to 100%. Anytime the humidity gets up above 80%, we start feeling it and it starts getting uncomfortable. And as it gets closer to 100%, I mean, the effects that we feel on our body are much more noticeable. I read a study once, some big air conditioning, it wasn't an air conditioning company. It was like an organization of air conditioning manufacturers. Did research on the most comfortable humidity for people, and I think it was around 40%. We don't want it to be too dry, right? Because your lips dry out and your eyes dry out. But you don't want it to be too high where you can feel it and it's all sweaty and gross. Very scientific terms, right? Sweaty and gross. So that we want that relative humidity to be kind of in the middle, but it certainly varies. And this vapor possible number, this would be if this number down here were constant, this would be a really easy thing to calculate. But this vapor possible number varies because different kinds of air can hold different amounts of water. But first of all, I'm going to use the word hold, but if we were being very particular, we wouldn't use the word hold. So we're going to use it. It's okay. But just every once in a while, someone wants to get really, really picky. We're going to use it. So different kinds of air can hold different amounts of water vapor. Warm air can hold more water vapor. Cold air can't hold as much water vapor. That's why if you think about the muggiest times of the year, they tend to be in the summer because that's when it's warm and the air can hold more moisture. And so even on days when the relative humidity is relatively high in the winter, it doesn't feel as muggy and gross as it does when it's summer and the relative humidity is high because there's so much more water vapor in the air. Now, when that relative humidity, if there were a situation where the relative humidity, this number and this number were equal, we would say relative humidity is at 100%, and that would mean that the air is saturated. Okay, so and that can happen. Now, usually that happens right about the time where you start getting some rain, or right when there's fog or dew or things like that, because anytime you have saturated air, it's difficult for the air to hold all that water vapor, and it has to get rid of some of it, and some of that water vapor ends up converting back into liquid form and being deposited there on the ground. So let's really quickly take a look at what happens over the course of a day. Okay, this is important because we understand that warm air can hold more moisture than cold air. So as temperature changes, relative humidity is going to change too, because temperature is going to change over the course of the day. You read in chapter 2 about the daily changes in temperature, right? How the coldest time of the day is right before dawn, and the warmest time of the day is a few hours after peak insolation, right? So if we start out at about dawn, right here, the coldest time of the day, that's when the air can hold the least amount of moisture. Right, cold air can't hold as much water vapor as warm air. So if the denominator of our fraction down here is a lower number, and the relative the water vapor in the air, which we're going to assume stays the same over the course of this day, the relative humidity is going to be a higher number. If the denominator is a lower number, and this number here, x, stays the same all day, well, x over this low number is going to give us a higher relative humidity. Then later on during the day, when the temperature rises, now as that temperature rises, it can hold more and more moisture. So as the temperature goes up to the high point, the ability of that air to hold water vapor is going to increase, and as such, the relative humidity goes down until the point of the warmest point of the day. So when the temperature starts falling again, as the temperature falls, the relative humidity will begin to increase. Okay, so temperature and relative humidity are what we call inversely related. That means when one goes up, the other one goes down. Okay, that's called an inverse relationship. And so when you hear the weather person talking about temperature and dew point, or excuse me, temperature and relative humidity, I keep getting ahead of myself. Temperature and relative humidity, you'll know how they're related. Now, dew point temperature is something you also hear the weather person talking about, and dew point temperature is an important process associated with these two things. What the dew point temperature is that's the temperature at which air is fully saturated. And when air is fully saturated, that means it's holding all the water vapor it can hold. Now, what happens if that saturated air drops one degree? Okay, so let's think about this. Let's say the temperature outside is 65 degrees. The relative humidity is 100%. Okay, if it's 65 and the relative humidity is at 100%, let's say the temperature drops to 60 degrees. When that temperature went down, the air can't hold as much water vapor. And since there's an inverse relationship between temperature and relative humidity, that means that the relative humidity would go up. But we're already at 100%, aren't we? So we can't have more than 100% relative humidity, at least not in this case. There are some rare cases, but we don't need to worry about that. So what happens? We're already at 100%. We can't be at 110%. Well, that means that some of that air, some of that water vapor that's in the air there is going to condense. It's going to go from water vapor back into liquid, and that liquid is going to either show up in the form of rain, or it's going to show up in the form of fog, or show up in the form of dew. A lot of times, sometimes you will wake up in the morning and you'll, you go out and you got condensation on your car, or you got dew on the grass. But it didn't rain last night. How's the grass wet? Well, what happened was that was that as temperature fell last night, and it got colder and colder and colder. As it was getting colder, the relative humidity was increasing, and as it increased, sometime in the night, 3 or 4 in the morning, as it got to as cold as it was going to get, the air couldn't hold as much of the water vapor as it had, and so it had to get rid of some. And so when you see those water droplets on your car, what you are actually looking at is condensation of water vapor that had been in the atmosphere or had been in the air, and that shows up as liquid water on your car windshield or your grass. Okay, gonna stop there, and we will see you in the next lecture.